course I turn it on and he does that. Sorry for the background noise. Brandon's in the kitchen cleaning something. I'm sure they can. It's a decent microphone. It's okay. Let's see if anybody's watching yet. Oh, there's 4 watching. Hi, everyone. Until people start asking questions, I usually just put some on here. Hi, Christina. You have a quick question. I'm assuming that's why you're here? Or is it just because you just don't spend enough time with me on Mondays? Oh, I should also mention, just in case you guys are curious, there's about a 10-second delay from when I say something and when you get to see it. It's just the nature of streaming. It's not instant. And it actually depends on how fast your computer is. So, hi, Jinhua. Jinhua sent me an email with questions. Okay. If you guys are watching me bounce my head back and forth, it's because to do this I need about 18 different screens open. Not 18, there's 5 right now, but So, Genoa, what you sent me, let's see. They were some nomenclature questions. It was regarding the naming of this molecule. Remember, you guys can always put these in ChemSketch to double check them too. You don't really need my help with it. So what I need you to see on this is actually there, she said, would ethyl be number 2? And there would be no ethyl anywhere on this. Because if you look, the longest chain in this, let me see, where's my drawing button? I don't think this lets me do one. If you draw the longest chain as the parent chain, oh goodness, no, that's not going to let me do it. The CH2, CH3 at the bottom would be part of the parent chain, so it would actually be 2,3-dimethylpentane. So hopefully that makes sense. Then you asked, would the tert-butyl be on number 3 or the bromine? That one we haven't covered yet on how to do that, so ignore that for now. You could put it on either for the sake of right now. We'll find out more later on. And then cyclohex 1-ene 1-amine. Yeah, looks fine. Nice job. Second iso, yeah. So there's kind of 2 different ways you can use sec, iso, stuff like that. And you'll notice for like N-propyl or whatever, we don't really use that if it's being used as a carbon substituent. But so for example, this molecule here that I just drew, if you followed that chain, you would probably look at that and say, this here is a methyl substituted ethane, right? Like, so we could look at this and kind of count the chain as having an ethane on it right here and a methane on it having right here. Okay? But what if I had, not that, something like this, where it might be easier to look at this as a longer carbon chain with one substituent on it. That would be an isopropyl group. So for me, I think isopropyl is easy to see because it just kind of looks like a V attached to something. So like this would be isopropylamine. This could be isopropyl, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5 isopropyl decane. And again, remember that the iso and the tert and the second, those are kind of an old school way of naming things. They're not really the approved IUPAC way of doing it, but you'll still see them used a lot. And so you can use it as like a carbon substituent on a chain, or you can use it as the parent chain itself when you're identifying something with a functional group on it. So what would be useful? Let's see. See if you can draw the following molecules. Do sec. Why is that doing script? like sec-butanol, isobutanol, tert-butylamine. That's not right. Butanamine, sorry. And see if you can kind of think about those and work those problems out. Another way that you'll see them is attached to rings. And I think that it makes naming rings that have a carbon, like kind of a complicated carbon chain on them, it makes naming those rings kind of easier. So in this example, you could call that isopropyl cyclopentane, or it would be 2-methyl ethyl cyclopentane. And so it starts to get really wordy, and you have to start using a lot of parentheses and things. So I would call that isopropyl cyclopentane, and a lot of other people would as well. So, sorry all that talking today. My voice is starting to go out on me. That doesn't happen often. I can usually keep talking. I'm letting you guys work on those problems, and then I'll answer them here in a second. You guys, we would be consistent with that, with the E at the end for now. So if you do the generate name thing, it'll give you the same thing, but you'll notice there's an E at the end of the cyclopentane. That's again just so you don't have a vowel or two consonants or two vowels next to each other. They do it that way. So both of those names would be, I'd give you 100% credit for both of those. This one follows the rules that we've learned so far. This one follows all the rules that we haven't learned yet. So, okay. Oh goodness, what did I do? Okay. So if we wanted to do sec-butanol, that is a regular butane that has a substitution on one of the second carbons, the secondary carbons. So that. Then if we wanted to do isobutanol, we would have to do an isobutane, which is one of the butanes that looks like this, but we are substituting it at that spot there. So remember, it has a CH2, a CH, and then it's equivalent. So there is a line of symmetry through it, meaning it iso. And then tert-butanamine. So I would need a tert-butyl group. And then an amine on that tertiary position. So hopefully that makes sense how you would use it that way. welcome. Next question. Hello? There's like 10 of you watching. I know some of you have to have questions. YouTube tells me how many of you are watching. You guys are just sitting here being quiet. I'll show you Twinkie, who's behind me on the floor, behind my chair. I have 2 other dogs on the floor in front of me, but I find it funny. Twinkie likes to smash his big fat body between the wall and this chair. I'm just going to start talking about basic and random things if you guys don't start asking me questions. Hi, Southern Bow Hunter, whoever you are. Makes TERT, ISO, and SEC. They're just basic definitions. Oh, hi, Megan. They're basic definitions. They're in your notes and they're in your book. So, I mean, it's just a basic definition of a specific type of structure. So we know that like a methyl group is a CH3. Isopropyl is a CH3, where something's connected to the middle carbon. And you just kind of have to memorize them. There's not an easy way around it, unfortunately. And if you remember, the TERT means tertiary, SEC means secondary, ISO means equal on either side, so those words do have meaning. Let's see. Alright, I have a cyclohexane. I'm going to see if y'all can do a chair conformation. Actually, both of them, because there are 2, right? Chair conformations come in groups of 2. I have like a hair in my eyelash, so if you guys keep picking at, or see me picking at my eyeball. Onyx has really fine hair, and it tends to get everywhere, including sticking to my eyelashes. Oops. Sorry, Onyx. Sorry. Didn't know you were under me. Trying to draw the molecule, but my stylus was under my bump. Let me see. Okay, Onyx. I got you, baby. I know. It's okay. Come on. Sorry about that. Onyx is having a bad day with her hips. She's very elderly and totally just fell trying to jump up on a chair. Go lay down. All right, Christina, let me look at your email. You guys work on that problem. Go lay down. Holly, so that's kind of what I was your question about naming cis or trans. Or some of you guys have sent me a few emails. I'm not having you guys learn how to name things cis or trans. There's a lot of examples in the book, but as I mentioned in class today, we would actually name those using R and S designation. I just need you to look at something and be able to tell if it's cis or trans. Okay, so we're not going to integrate that in with any of the naming. And then I was going to do the diaxial interactions coming up here in a second. Who sent me that one? So Arang, the problem you sent me is one where we wouldn't, if you numbered that either way, left or right or left, I would give you full credit right now. Actually, I wouldn't try and give you one of those problems because we have not learned what takes precedence if numerical doesn't work. Okay, so ignore that problem for now, or just pick whichever way you want to number it for now is fine. Christina, I don't see an email from you. Reload it. Not yet. Oh, I thought that said Christina that asked a question by email. It was wrong. Sorry. I forgot that you go by Chloe also. I just saw the C and assumed that it said Christina. To make sure I have all my windows up, I have a lot of them shrunk very small so I can see when you ask things. So, okay. So I'll get us back to this problem then, because some of you are asking questions on this kind of thing. So if we wanted to do chair conformations of this, you can start off with either one. I actually prefer the pin. Let's see. Mine aren't quite as good using the computer as I do on the board, so sorry about that. So we need to identify one of these carbons as carbon 1. Let me change the color so we can at least have a starting point. So, and it doesn't matter because remember, these are rings, you can turn them. But I'm going to go ahead and identify the one pointing down and then up in that position is carbon 1 that has a OH on it. So remember, if it's pointing up, regardless of whether it's in the axial or equatorial position, right? So at carbon 1 on this first ring, the one that's pointing up, wow, that's terrible looking. Let me try that again. Is in the equatorial position. It still doesn't look great, but I think you can kind of see it. I'll call that carbon 2, 3, 4, 5, and 6. So I numbered that counterclockwise, so I'll do the same here. So 1, 2 would be there, and 3 would be there. And 3 has a methyl group pointing down. So in this position, at that carbon, on that part of the ring, the one that's pointing down is in the axial position. And then at carbon 4, the one pointing up would be in the axial position as well. Okay. Now, when we do the chair flip, that OH that was in the, that was right here on the equatorial position is now axial, but it's still pointing up, right? So, still pointing up, just different. Carbon number 2's right there, 3's right there. Instead of pointing down on the axial side, the one that points down at that position comes out like that, away from the ring. That's supposed to be a 3. And then the one next to that is pointing up, but axial, or instead of axial, it's equatorial. Okay. So, again, if you're having trouble seeing those, you can try and use a model kit. That helps a lot of people. But now a question that we could ask for that is, excuse me, is how many 1,3 diaxial interactions are there? Meaning, which ones are more stable, the one on the left or the one on the right? I would think at this point you've probably worked enough of these that you can look at them and tell, but what I'm going to do is I'm going to put in kind of the relevant hydrogens here in green, meaning the axial hydrogens. We don't need equatorial hydrogens to do 1,3 diaxial interactions. And then let me do these. So you'll notice that on the one on the left, it has 4 hydrogens that are in the axial position that would be able to interact with non-hydrogen groups also in the axial position. On the right, there's only 2, and that's because the ones on the bottom are all hydrogens, and we don't have 1,3 diaxial interactions with just hydrogens, right? So let me draw some. Okay, so there is a 1,3 diaxial interaction there that kind of connects that carbon and hydrogen. And then there's one between the carbon and the other hydrogen. And then this carbon and hydrogen, and that carbon and hydrogen. So this one has a total of 4 1,3 diaxial interactions. This one over here, it's the hydroxyl group that has them. So there's one there, and there's one there. There's none on the bottom because there's nothing axial on the bottom other than hydrogens, meaning there's only two. So we would expect this molecule to be the most stable version. Because it has fewer 1,3-diaxial interactions. Okay? So hopefully that makes sense. If you just needed one extra example, Holly asked for one extra example, so that plus the few you guys have in your book and the few that you have in your notes should probably get you kind of where you need to be on that. We did talk a little bit, I mentioned the other day, we talked a little bit about how some of the groups that you could have different levels of interaction based off their size. We're not going to go there. We're just going to look at straight 1,3-diaxial interactions and like the full number of that being more or less the entire issue of stability. Why don't we take this one molecule, the more stable one, crop the rest of this out. There we go. Let's take and do a Newman projection of this, looking down that bond and that bond. So that's our eyeball looking down that direction. So what you need to look at is the fact that when we have our two Newman projection rings for this carbon here that I just circled, do it again in case you weren't looking, that carbon there that I just circled is pointing up. So when I do this, I need to have a carbon in front that's connecting those other two sides. It needs to be pointing up rather than down. Apparently my dogs need to go outside, so work on that for a second. You're gonna hurt yourself. Onyx has always been a very agile dog, and now that she's aging, she refuses to agree with the fact that she can't do certain things anymore. With my stylus. Oh, this was a bad example to give you guys. I'm sorry. I told you. If Vincent's watching this, not Vincent, Victor. Was it Victor or Bradley that were like, what would happen if we had one out the front? I said, oh, we won't worry about that. Well, I kind of just gave you one on accident. I'll go ahead and put the OH here on the front, sticking straight up. I think that'll make it easy to look at. And the one, we'll just do it that way. I'll have you guys fill in the others. That was not intended to be a really hard question. The one that's in question here is this carbon right there, because it has that methyl group coming off on it. So we have to look at this and figure out which carbon that is. And it is, I'll change my color there. It's this carbon right there, the one that's behind there, okay? And that CH3 here that's coming off is coming off in the equatorial position. Now notice, each of the bonds that we see on the Newman projection are showing you axial or equatorial, right? On those circles. Like this one, and this one, and that one, and that one are all equatorial. They're pointing out to the sides. They're still pointing up or down, but on an angle out to the sides. And then the ones going straight up and down, those are your axial positions. So that methyl group is coming off on that position back here. Okay, it's pointing down and in the equatorial position. So the rest of these still need hydrogens on them, because if I don't put hydrogens on them, they mean methyl groups. And we know that that is not the right molecule. It did not have that many methyl groups on it. Okay. So hopefully you look at that and it looks like a child took a pack of crayons and just started drawing randomly, but I swear that's organic chemistry. My handwriting's not great on the best of days. Using a touch screen on a computer, it's even worse, and I'm sorry for that. Look at my chat box again and see if anybody's asked me anything. That would be fun to do. Let me do this. Let me do this. Let's do, whoa, 2 Newman projections. Kind of drawing these elongated. Oh, that's not how I wanted to do that. I wanted to color code it. Hold on. Put you guys on mute for a second so you don't have to hear me scream. Hey Brandon, can you help me with the dogs down here? I keep having to get up. I need help. Trying to get my husband to help me with the dogs instead of me keep getting up and doing things. Okay, so what I wanted to do is color code the axial and equatorial positions. Yeah, this would be, that would be it. So you'll notice these are the 2 flips of each other. So on these examples, the orange would be the equatorial positions that are coming out the sides, and the axial positions are the green ones going straight up and down. Okay, so remember, right, something when the chair flips will still be up or down, depending, but it doesn't flip whether it's going up or down. It just changes whether it's axial or equatorial. So you'll notice that these are two versions of a chair flipped, right? So this position here, when we flip that, it still points up on that same carbon. Okay. This one here is pointing up, but equatorial. Now it's pointing up, axial. Okay. So hopefully, you know, if you were still struggling with that, that makes some sense. Just kind of color coding it. Thanks for letting them in. Holly said, with the example we did when drawing a chair, does it matter if you begin with axial or equatorial? Not if I don't ask. I mean, if I say draw two of them, you know, you have to draw both. And you can start with whichever one you prefer.
I'm giving you ideas.
Brandon just said you guys are giving me ideas, but I already wrote the exam. Nothing's changing. Except I need to proofread it. I need to proofread it. Hey Brandon, Onyx tried to jump up on the chair and just like completely fell on her butt, upside down on her back. She tried to do it without taking any kind of running jump. She just tried to walk up there and it did not end well for her. I put the pad there just in case she falls again. I probably have about 18 pre-vet students right now horrified that my elderly dog's doing this and that I'm letting her. But she does it when I'm not here. I can't stop her when I'm not here, so.
You just not like being picked up?
No, she doesn't like being picked up and she doesn't like being told she can't do things. She's elderly and in denial. She's like the old person that needs a walker but they won't use one because they're like, no, I don't need it. That's for old people. Go over there.
Huh?
Yeah, maybe we should just keep that mat there for her.
Okay. Well, she likes that chair.
Okay, well, we can put it in front of this chair. Or maybe we should get two mats. I'm sorry you guys are having to hear about our struggles with our elderly dog. She's a special animal. What do you guys want from me? You're not asking me questions. So, okay. Well, if there are no more questions, I'm going to hop off because I don't feel like staring at the computer by myself all night with you guys not asking anything. So if you have questions, you can email me tonight. Brandon. And I will see you guys in the morning. I will be able to answer questions until probably around 10 or so. And then, yeah, I think we're good from there. Okay. If that's it, I'll see you guys in the morning. You're welcome, Megan. Good night, everyone.
What?
Oh, I have a student named Megan. Brandon's confused.